going to learn how to tell whether or not a certain or given series converges via the series integral test. Basically, this means if we have a certain sum, which can be represented by a sigma, and it starts at I equals 1, and it goes to infinity, and what we actually have in our sum is, let's say we have 1 over I. So this will essentially represent 1 over 1 plus 1 over 2 plus 1 over 3. And we want to tell whether or not this series, when it goes to infinity, like 1 over infinity, will it converge or will it diverge? So if it converges, that means it's going to be equal to some finite amount. For example, it can equal 2. If it diverges, that means it's going to equal either positive or negative infinity. Now, on first glance, we see that, okay, 1 divided by infinity, that's obviously going to go to 0. So, I mean, after a certain point where it looks like we're not going to actually see any change in the series must converge. However, that thinking would be wrong. And the only way to tell is with the series integral test. Basically, what we're going to do is turn the sum into an integral. So now we're going to take the integral from 1 to infinity of 1 over x with respect to dx. So now, once we do this integral, we note that this 1 over x is going to go to, remembering our basic integral rules, natural log of x. And let's just plug in infinity and 1. So we have natural log of infinity minus natural log of 1. And we know that natural log of infinity, that's actually still going to be infinity. Not, well, natural log of 0 is just going to be 1. That means this is going to go to infinity. We're never going to actually settle down at a concrete value. So we can say with confidence, this diverges. Okay, now let's look at a second example. In our second example, let's look at something very similar. We're going to have I going from 1 to infinity. But now we're going to do 1 divided by I squared. So this is going to look like 1 over 1 plus 1 over 4 plus 1 over 9, dot, dot, dot. And it's going to eventually go to plus 1 over infinity squared. Now, when it comes to infinity, if we have 2 times infinity, that doesn't seem to make a big difference. But if we have powers in infinity, then we're going to start seeing changes that are they're going to matter. It's just like how when we calculate limits, we sort of ignore the lower power terms and only look at the highest power terms. So taking the integral of this from 1 to infinity, okay, it's 1 divided by x squared with respect to dx. So what's that going to be? So we can see that as x to the power of -2. That means if we just do the rule that we have for integrals, it's going to be a negative x to the power of -1. That's what it's going to come out to, and let's plug in what we have here. So this is just going to be equal to -1 over x. Now plugging in what we have here at the beginning, let the infinity and the 1. So it's going to be 1 over infinity minus, well, plus now because the minus and minus become a plus. And we're going to have 1 over 1. So the 1 over infinity, that's 0. It's taking a really small numerator, a really big denominator, of course, relative to each other. And we're adding the 1 on the end, so that's going to be 0 plus 1. That's going to be equal to 1. So we can confidently say that this converges. And that's how you use the series integral test. Thank you for listening, and I hope you learned something today.